All right. Yeah, thanks. So I'm based in Austin. On the last slide, I will link to my hiring URLs if you guys are interested. Um, yeah, so I work at Trinet. I get to work with some really sharp engineers. Jamie was one of them. Um, and, we work on some pretty complex applications. Throughout my career, I've run into bad situations where you inherit a messy code base. I have perpetrated bad code. I've been in bad situations, and over time, I've learned a lot of things along the way working with really sharp people. And one of the things I've always pursued is trying to get to a point where doing things the right way doesn't have to mean doing things more slowly. So, has anybody here ever inherited somebody else's code and been afraid to modify it? Show of hands. All right, okay. Have you ever been scared of your own code? I have. And so that's kind of why I want to jump into this talk, because I think there's been a lot of wisdom in software engineering that has existed for decades, and I think that we have the opportunity to embrace this wisdom and apply it to our modern day architectures. And today I want to try to answer three basic questions. What makes software not fun today? Where does it hurt us? And can we make it fun? Now, the punchline of this presentation is going to be test-driven development. If you look at the bottom of the slide here, test-driven development, if you do it well, is a way to make software a lot more fun than it used to be. And to also really explore, because a lot of people equate unit testing and test-driven development as getting things done more slowly, but I'd like to challenge that, and I will try to demonstrate that, toward the end. But ahead of that, if you go one layer up, we're going to have to look at what it means to do test-driven development in web applications. And we're going to look at web application architectures and how we can facilitate test-driven development with the right architecture. But when you talk about architecture, if you go one layer up, object-oriented programming is a tool by which you can achieve more decoupled architectures that allow you to write better software. And then before that, we're going to look at, some enabling concepts of better code, and that's when we're going to touch on some design patterns. And then right now, we're going to jump into, bad code, the impact of bad code on agility. So yeah, let's jump into it. So let's look at bad code and the adverse impact that it has on, what you call agility. So Uncle Bob has famously said, it will be a long time before I trust software to drive a car I am in, because I know software can get bad, and it's pervasive in our lives. And, you start seeing it in cars these days. Tesla is famously doing that, of course, and many, many other car manufacturers. So, of course, the first thing you would ask yourself is, what could possibly go wrong? Obviously, this could go wrong. This is an instance of software being a little too good that it became self-aware. Sadly, we're not at that stage yet. So let's look at the impact of bad code against having fun. So as we just looked into, it's never fun to inherit somebody else's code, especially when you have to become an archaeologist to understand what it means and what was the intended functionality. And then you try to build new things, and when doing that, you're going to break a lot of legacy functionality, and that's never fun. And to avoid introducing bugs, you need to be testing a lot, right? A lot of manual testing, and we don't enjoy that either. So you hear a lot about agility these days, right? We are an agile shop, and usually, for most companies, when it comes to becoming more agile, they're going to look at three main concepts. So the first thing that happened a while back is we reinvented project management and task planning, and the Scrum process came out, and Kanban as well as another agile methodology. Then we looked at the challenges that we have with moving code from one environment to the other, and how we could script running unit tests, for example. So this is kind of when we, I started adding a lot more tooling around continuous integration and continuous delivery. So that's great also. And then every few years, there's always a new MVC framework coming out that will solve all of your problems, right? Obviously, beneath all this, there's an underlying issue that looms, and that's bad software. What's going to happen is, as you accumulate a lot of technical debt, your Scrum process is going to be a lot harder to achieve on time. So your 1 or 2 week sprint, if you're trying to get something done in a code base which has a lot of technical debt, you're going to keep missing those deadlines, or you're going to ship stuff that's really not completely done, and you're going to have to put it back on the backlog. If you look at continuous integration, if you have a lot of bad code where you have big monolithic classes with thousands of lines of code, and you have a bunch of people modifying the same class, for example, that's a code smell. You're going to get a lot of merge conflicts, right? So your continuous integration is just not going to be a fun process. So overall, if you look at your bad software, it eviscerates just about every benefit of your agile stack. And Martin Fowler wrote a great article on that. It's called Flaccid Scrum. So I highly recommend reading this, and it just touches on the impact of technical debt against doing Scrum. So in that sense, we may think we're agile, but we're not, as long as we're writing bad software. So let's look at the impact of short-lived agility on your ability to constantly release new features. And before doing that, let's just look at technical debt. The very first thing we're going to do when writing bad software is accumulate astronomical amounts of technical debt as the project evolves. And then what that does is, over time, you're trying to release new features, and you start out on your project, and you're able to release new features at a pretty decent pace, right? Right up until you start going down there, and when the technical debt gets really bad and you get to the bottom right of that graph, that's when it takes you a near infinite amount of time to get nothing done. And that's really not a good place to be. And in that case, we're not agile. So now let's look a little bit at the business impact, right? Especially if you look at a startup. You just got funding, you got your MVP product out, and you start out, you have a limited amount of technical debt, so you can get, your business value is going to go up, at least the perceived business value, because you're able to get a decent amount of new features at a decent pace. But pretty quickly, your technical debt is going to start weighing you down, so you're going to plateau pretty quickly. And then what's going to happen is, as your users engage with your application, and you want to make some significant adaptations of your product to your user demand, or you want to do something more radical, like a pivot, it's going to be very hard for you to do so, very hard and maybe impossible. And that's when your investors start losing faith in you, and they start looking for an exit. Meanwhile, your competition has been sitting on the sidelines looking at your successes and your failures. There are a bunch of companies out there, and if you look at how many Uber clones there are out there, right? They'll look at what's successful, and they're going to try to replicate that. And they're going to be able to start from scratch without the weight of all that technical debt, because they're starting over. So while you're going down, your competition starts to take over. And that's when things get not fun. You're putting your competition in a position to drink your milkshake. So I highly recommend this talk by Uncle Bob, Robert C. Martin, on the future of programming. It touched on these topics, especially toward the end of the talk. So now that we've looked at the impact of bad code on your business, let's look at some enabling concepts for writing better code. So I like to look at three concepts: test-driven development, clean code, and patterns, like design patterns, for example. You could argue that all three topics should fall under clean code, and that makes complete sense. But I like to kind of isolate them and call them out separately because it kind of helps with the learning process as we improve our craftsmanship. So as far as TDD goes, we're going to touch on that at the end of the talk because we're going to build up toward it. When it comes to clean code, I highly recommend Uncle Bob's book on the subject. I would hate to do a whole talk on paraphrasing it, but it's really going to show you how to write code that is more understandable, more meaningful, more understandable, and more maintainable over time. It's also going to show you a number of refactoring patterns to take existing code and improve it. It's also going to show you a lot of different code smells, and he's going to use a number of design patterns to show how to to convey all these concepts. So I highly recommend the book. I don't want to paraphrase it in a talk, but it's been one of the most impactful books I've come across. So yeah, highly recommend it. So now let's look at patterns. There are a lot of different programming paradigms, right? So, we all know about these: object-oriented programming, procedural, imperative, and functional. So with with procedural, you're going to be able to stash functionality into functions and kind of call them and then kind of call them out. With imperative, you're allowing yourself to have side effects. Functional would be the opposite of that, where you encapsulate almost everything in well-defined functions that do not have any side effects. And if you look at these paradigms, you should really think about them as an opportunity to seek out design patterns for them. They're only as useful to you. They're only tools really to seek out and apply best practices and patterns against those paradigms. And the goal behind those patterns, it's really the goal in any software system. You want to simplify complexity, right? Any software system you're going to start out is going to start out simple, but over time it's going to get more complex, and you want to be able to manage this complexity, and design patterns will definitely be very impactful in doing that. So, if you look at those programming paradigms on the left and the patterns on the right, some of these patterns are more well aligned to certain paradigms, like the Gang of Four design patterns apply more toward object-oriented programming. But the solid principles could be most of them can be applied to both object-oriented programming and functional programming. And then you have Martin Fowler's enterprise application patterns, which are higher level patterns, which could be leveraged in almost any of these paradigms. So if you're interested in learning more about patterns, we can do a whole talk on that. So I just kind of want to give you some resources. If you happen to write in PHP, this first link gives you a bunch of the design patterns, the Gang of Four design patterns, nicely categorized by topic with explanations and code examples. And if you work in Java or C#, you can just read this as well, because the code is just OOP. So it's absolutely applicable to Java and C#. It's really easy to do. If you're interested in functional programming patterns, I have a number of links here. So I have the talk on F#. Also a link to streams in Java 8, which allow you to apply functional programming patterns in Java, which allows you to offload processing to different cores or even GPUs, or even distributed machines. Uncle Bob has a talk on functional programming. Goes over some of those use cases. I also highly recommend Anjana Vakil's talk on the subject. It's a really good intro to functional programming, with an intro on persistent data structures, which is very interesting. So to go back with object-oriented programming with my teams, we kind of looked at some of the design patterns that we use the most every day, 0 being used the most, 3 being used the least. And these are some of the patterns that we come across. I'd always be interested to see what patterns you guys come across whenever you build, whenever you write software. But in our context, when building web applications, we come across these patterns, pretty often. So try to keep in mind these 3 things: test-driven development, clean code, and patterns. So we looked at some patterns, some OOP patterns, and we noticed that object-oriented programming is one way to achieve a good set of design patterns. So I want to touch a little bit on object-oriented programming and ways to empower it, because you tend to hear a lot of controversy around OOP, and a lot of what's being done, a lot of what's being railed against is what I would call OOP done in a flaccid way. And some of the symptoms that you'll see are things like, random instantiation of classes all over the place, which will result most often in unpredictable system coupling. You can look at a class and it's going to be really hard to know what the state of the system should be whenever that class is being called. And you'll see all kinds of violations of the law of Demeter. And so these are some of the symptoms of using using OOP constructs in an indiscriminate way. In other words, just because I can instantiate a class, I'm just going to instantiate a class in my code, and I may have a controller that instantiates a model, which instantiates another model, which may instantiate another controller. I mean, you'll see some pretty wild things out there, and this is kind of the symptoms of what you'll see out there. So to get back to at a higher level, when you're doing OOP, you should look for those goals. And really, they're pretty broad goals, right? I mean, at a high level, you want to be able to write a simple, maintainable system. And a good way to do it is to have loosely coupled components with a consistent dependency graph. And to do that, you're probably going to embrace design patterns, OOP design patterns, to achieve that. So I really want to stress the importance of embracing design patterns, because if you're not doing that, you're really technically not really doing OOP. And you could say the same thing with functional programming, right? If you do functional programming, but you're not embracing kind of the best practices and patterns of functional programming, you're really not playing to the strength of this paradigm. So if you're going to do OOP, I highly recommend really embracing design patterns. And we're going to look a little bit at what it means to embrace some of these patterns in the context of web application architectures. So we've all heard about MVC. It's been around for a long time, actually since the 60s, I believe. And it's been applied a lot in web applications. And in my experience, it works pretty well. When you're trying to basically do little more than scan your database, where you have one URI that performs one of the create, read, update, or delete operations. That's when it works really well. And that's nice when applications start out simple, but then obviously they always get more complex, and you start adding more and more business logic, and you're finding yourself yearning for a true place to put that business logic. And you've seen debates, putting the logic in a controller versus putting it in the models. In the end, you don't want any single layer to get too big. So another challenge is the early frameworks tended to impose a lot of tight coupling between those layers, model, view, and controller. I'm going to show you an example of that, but especially between controllers and model, right? It's pretty typical to see something like this, where you have a controller which instantiates a model directly. And it works, right? But if you're trying to write a unit test around this controller, Well, it becomes hard because now it's really coupled to this user model, to this specific implementation of a user model. And if you want to mock it out or fake it out, it's going to be close to impossible to do it. So a better approach is to embrace dependency injection, which is one of those patterns that we just looked at, right? So if you're going to use a model on your controller, you might consider passing it right here as an argument of the constructor of your controller class. Because then you could override the implementation of the model and you could pass a mocked implementation or a faked implementation. An even more convenient way to do this is to code your controller against an interface of the model that it does, because now you're kind of guaranteeing that your controller is not coded against a specific implementation of the user model. So at a high level, when working with web applications, you want to try to have a lot less coupling. You want to promote things like dependency injection, which is a pattern. If you look at your project, you're probably going to want to have a lot of small files, because if you see a lot of small files, it means that you end up with a lot of small classes, which means you're likely to be complying to the single responsibility principle. SRP is part of the solid principles, which we looked at it at a previous slide. But to make this happen in the context of web applications, you're probably going to need a few more layers than just M, V, and C. So you may have seen this architecture. There's nothing too groundbreaking here, but you're still going to have your views and your controllers, but you're going to isolate them into the yellow zone, and we're going to touch on what that means. But now you're going to add a couple more layers: commands, services, and repositories. So you could see your services as your capabilities of your application. It's going to be your API. And your commands should be a myriad of very specific use cases which leverage those capabilities. So in a typical project, you may have dozens of service classes, but you may end up with hundreds of command classes, depending on how complex your application is and all that stuff. Now, in some projects, you might not even have a command layer, because you might just expose you might just expose API endpoints straight to your service methods. That's also possible. But you might still use commands to cater to different use cases. So, you have options there, obviously. And then repositories would be responsible they would be your data layer, basically, right? They would interact with your data store to retrieve data and to modify data in your data store. Now, entities would be representations of your business domain. A user entity has roles. You can have a ride event, which is linked to different rides. These would be your business objects. And they're really pretty simple. It's a pretty simple object graph, which is agnostic of any framework. It has limited logic. But basically, your repositories would return collections of entities, or you would pass an entity to your repository to save it to your data store, for example. So between those layers, I like to extract interfaces, because it allows me to swap out implementations later on, especially between a service and a repository. And we're going to touch on that a little bit later. But overall, in this green zone where I mentioned 100% unit test coverage, the goal here is to build everything that's in the green zone in a test-driven way. You could build controllers in a test-driven way as well, but I'd like to keep the controllers really, really small, so they do nothing more than call a command, and or one or several commands. but I won't even put an if statement in a controller. I won't even put a for loop in a controller. I will try to abstract all of this in my commands so my controllers can really stay as small as possible. And part of the idea behind this is to keep your yellow zone as what I like to call the irrelevant zone. It's a bit extreme, but it's the key is that your yellow zone is coupled to your transport layer, right? HTTP and HTML. Your business, in an ideal world, shouldn't care at all about what that transport layer is going to be. And then your business should also not care about what framework you're in. You know, whether you're in Symfony or Zen or Laravel, your application layer your business logic should not care about that. And then on the flip side, that green zone is what I like to call what matters, right? Would be most of your code base, because like obviously now it's transport agnostic, and it's also framework agnostic. So let's touch on repositories again. I mentioned earlier in this graph, oops, sorry, let me go back here. You see this interface between your service and your repository right here, right? The goal here is that you can swap out the implementation of repositories. So today, you may have a repository which happens to use an ORM, for example, which is backed by a relational data store. But then your application may evolve. You may end up in a scenario where one of your data sets, it could be, your events, for example. You're getting an infinitely growing set of events every day. Let's say you're adding 10 million events every single day, and there's no end in sight. That's going to be, you're going to start running into limitation of a traditional RDBMS without doing things like sharding. So at that point, a NoSQL, transitioning your application to a NoSQL solution might make a lot of sense. And going from a relational schema to a document store is very easy to do. And if your application is coded against an interface of your repository, then you can just swap it out. So if you look here, today you may have a repository that's bootstrapped to a service, and this repository happens to be backed by an RDBMS. Tomorrow you can swap in a repository that's backed by a NoSQL solution, and your service layer is not going to care because your service layer is coded against an interface of your repository layer. And so you can achieve similar concept with using an ORM versus not using an ORM, right? If you get under a high enough load in your application, let's say you start doing 10,000 requests per second, your web server might start running into limitations, into the certain overhead of all the objects that get created when using an ORM. You could make another repository implementation which happens to use raw database connectivity, and it could still return collections of entities to comply to the interface that you define. So that's the thing about a good architecture, is it allows you to, one, delay decisions, and also change your mind later down the line as your business needs evolve. So there are a couple of great talks about this. So here's another video by Uncle Bob on the clean architecture and a related article that he wrote on this. All right, so now that we've looked at architectures, let's see, and we looked at web application architectures and applying OOP concepts for them. Can we put it all together and doing test-driven development? So first, let's look at what is test-driven development. So by and large, your consensus for that is you write one failing test. You write just enough code to make that test pass, and then you refactor. It's also known as red, green refactor. Here's a pretty graphic to say just that. So why would you want to do test-driven development? I like to put forth two arguments. One is speed, and that's a more controversial one. And the other one is change, being able to change your system. Because if you're doing test-driven development the right way, then by definition, your code has 100% code coverage. And if you have code coverage, it promotes change in your system. So what's going to happen often is when you do test-driven development, you're not going to right away see what the optimal patterns are, what the optimally clean code is. And when you start out on your project, you might compromise on those. But because you're doing test-driven development, you're never afraid to improve your code. You're never afraid to refactor it to a more ideal state. You don't have to get there right away. You don't have to spend hours thinking as to what the optimal design of the system is going to be. Just write some code, get it done, ship it, and then as you evolve your code, you can always refactor it very easily. It takes a couple minutes here, a couple minutes there. You're not afraid to do so because your tests have your back. And I like to distinguish between doing unit tests and the mentality of test-driven development. Because doing unit tests is like doing after-the-fact testing. So you've written all this functionality and you've tested it manually and you're pretty sure that it works. And now you face the daunting task of covering this code after the fact with unit tests. That's never fun. With test-driven development, like I say here, you're really only ever coding to your assertions, which means you're not doing duplicate work. And we're going to look at what exactly that means. But there are challenges, obviously, because when you try to get into test-driven development, there are a lot of really good tutorials out there and a lot of really good code katas to do that. But they tend to focus on very simple algorithmic problem, and they don't touch heavily on what it means to deal with dependencies, because you're in a complex system and it has many layers, and that's the case of web applications. Web applications have several architectural layers. They have many classes. They do a lot of data I/O. So you want to be able to deal with all this. And you want to get into your unit test harness, and you want to get the satisfaction of building end-to-end functionality without leaving the comfort of your test harness. And what I'm going to try to demonstrate is that doing this is definitely going to be faster than testing after the fact, but it can and it should be faster than building things without doing any unit tests whatsoever. And the goal here is to not pit better against faster. It's to really embrace the fact that better can and should fuel faster. So that's definitely something I'm interested in. And so you might ask yourself, where do we waste time today, right? If I'm saying doing test-driven development can save you a lot of time, where do we waste time today? And I like to look at two topics where we waste time. We waste time while building things and while checking things. So let's look at where we waste time while building things. So when you start out in a new project, you're going to spend a good amount of time setting up your local database, your local MySQL database. You're going to think through your first body of use cases, and you're going to start creating a database schema and interrelate the tables with one another. You're probably going to want to scaffold a basic user interface so you can actually interact with your application with everything that you build. So you'll definitely spend some time, a good amount of time hooking up your controller to your view and making sure that you've got something you can interact with. Then you're going to write some code, so that's good. As you do this, though, you're probably going to run into some issues. So you might start using a debugger to step through your code step by step. And if you're not using a debugger, you might start using, log statements to kind of trace the behavior. And then when you check things, let's say you've built a decent amount of functionality, now you want to check things, you're going to go into your user interface and you're going to click on your user interface to get your application at the specific state that you're trying to trigger for the business logic that you just wrote. You're probably going to spend a good amount of time looking at database records to make sure that whatever you just did inserted or modified the proper value that you're expecting. If you want to skip messing with the UI, you might modify manually some database records to jump your application into a given state. And you're probably going to realize that you just broke a bunch of things while building new things. And so if you think about all these lines that I just wrote in red, in this slide and in this slide, they're basically throwaway activity because they're very manual, they're repetitive, and they're only relevant once. They're relevant only at the time that you're doing it. But in the end, I always want to be building things. And when you code against assertions in a test-driven context, all you're ever doing is writing a failing test, writing some code to make the test pass, and then refactoring. And every single one of those activities are foundational. They remain perpetually relevant because with each test that you write, now you have a regression suite that will have your back going forward. Now, the challenge, though, is, okay, that's nice in theory, but you still, we looked at all those architectural layers, right? View and controller and command and service and repository. You want to be able to work effectively with those boundaries. And, you're also going to have data in your tests, right? You want to be able to make sure you can accurately save data, retrieve data. So the big question is how. So a way to do it, which has worked really well for us, and it's had a really massive impact, is to use our test harness, right? Take any unit test harness that conforms to the XUnit standard. So it could be PHP unit, JUnit, NUnit, JS unit in JavaScript. You're going to bootstrap an ORM inside of your unit test harness, and this ORM is going to be configured against an in-memory database. So we're going to start there. And then we're going to start building things on top of it. So your first test might look something like this, where all you're trying to do is verify the fact that you can create and save a new user. So you're going to create a new instance of a user entity. You're going to give it, you're going to assign it, let's say, the first name and last name. And you're going to save it into your ORM. It could be through your repository. You want to save it. And when you create your new entity, you're not going to give it any ID. You're not going to even expose any method to set the ID. But you're probably going to expose a method to get the ID because you're going to need it here. And you're going to want to verify that your ORM assigned the proper ID to your new entity. And that's a signal really to indicate the fact that, okay, your entity got saved properly. So this is red and green, meaning red, I just wrote a test, and then I wrote code to make the test pass. Okay. So now I'm going to refactor because what I just did is going to be useful. Yeah, I wrote a test, and I wrote some code to save a new user into my data store using the repository class that I just created in the previous test. So I'm going to extract this into a convenience method inside of my unit test, and then I'm going to use it in my next test to verify that I can retrieve a user. So test user retrieval now is going to assume that you have a saved user in your repository from test one. So you're just going to call this method. And now you're going to retrieve the user from your repository by ID. And you're going to make sure that the user that you just retrieved is the same as the user that you just saved. And you can compare properties on it. And that's basically it. You can follow this step. You know, if you look at a bunch of use cases, you're going to first focus on your creational use cases for things to enter your system, for a user to enter your system, for a location to enter your system, for a new ride to enter your system. And then you're going to write more tests to do business logic around these concepts. But basically, once you get this down, it's really easy to just keep building things, and you just get into a rhythm where you can get things done really fast. So one way to do it is to use an ORM which conforms to the data mapper pattern, and it's worked really well for us. If you look at Hibernate in Java, it's been around for a long time. Eventually, the open source project Hibernate, the entity manager interface that they defined actually became part of the Java Persistence API, which now means that any open source project can conform to the Java Persistence API, and any application that's coded against that interface will interoperate nicely with that ORM. So now you're not bound to this one open source project, even though right now it's the one that's prevalent. Now in PHP land, the Doctrine project was created as a port of Hibernate into PHP, and they have evolved in parallel with Hibernate. So basically, what I just showed right now, if you can do it in Java or PHP, if you can do it in Java, you can do it in PHP. If you can do it in PHP, you can do it in Java. So this is kind of where you got really nice pollination of concept across ecosystems. And if you work in .NET and C#, you have the N-Hibernate port of Hibernate in .NET. And Microsoft also has a framework called the Entity Framework. So N-Hibernate should have the exact same APIs as Hibernate, and then the Entity Framework should have a similar API. Okay, so let me just kind of skip over that. So here's an example. If I am in PHP and I want to start building my first unit test, I'm going to use this base test. I call it app test case. And all of my tests, or most of my tests, are going to extend this class. And this class only does one simple thing. It gets it gets an instance of the ORM from the framework, and then it resets the entire data layer. So with each test, it's going to recreate the entire schema based on all the entities that are currently in scope. And the goal behind this entire flow is to forward engineer your entire data layer through unit tests and entities. In other words, you can build most of the functionality without even touching your RDBMS, your local RDBMS instance. Everything can work inside of your test harness. And I'm going to show what you do at the end when you're done with that. But this is kind of a simple way to set up an entity manager so that with each test, it recreates the entire schema. So in PHP, I've done it with PHP Unit, the Doctrine ORM backed against the SQLite in-memory database. I've done this in Java as well using JUnit, Hibernate, and HSQLDB. I haven't done it yet in C#, but I've researched it, and I want to play with it in Visual Studio. If one of you wants to help me with that, that would be awesome. But I think in C# we can do it with NUnit, Microsoft's Entity Framework or NHibernate. It's probably going to be easier. And then using SQLC. There may be some other tools, but that's what I could find with my cursory research so far. So as you get into this, you really want to commit to the process of test-driven development, and you want to enforce it with code coverage tooling so you can enforce 100% coverage. And you also want to have peer code reviews to verify that all your tests have meaningful assertions. As part of one of the most critical thing that a peer reviewer can do is look at your unit test and compare the assertions of your unit test against the business needs, against the use cases that you're trying to deliver, and try to find holes, because it's always going to be possible, right? 100% test coverage does not mean bug-free. Your code is only going to be as good as your assertions. So you basically don't want to end up with less than 100% code coverage, because if your tooling calls out 99% line coverage, for example, it means that at some point you shortchange yourself in your test-driven development process. You probably wrote some code ahead of having a unit test for it. So you want to do it the other way around. And then here's a trick. As I just mentioned, it is possible to have 100% code coverage and your code being littered with bugs, because what happens is developers covered code after the fact and they wrote meaningless assertions, right? They were not doing test-driven development. They just wrote a bunch of assertions on the existing code, and those assertions were not meaningful enough. So you don't want that, and this is where peer code reviews really help as part of this process. So when you do test-driven development, you might look at inside out versus outside in. So inside out would mean that if you have a large system with a number of use cases, you might do some upfront design, just enough upfront design to break it out in discrete components, and then do test-driven development on each single component. Now, if you do outside in, you might start doing test-driven development against the larger system. So you're not necessarily spending a lot of upfront design preemptively breaking things into discrete components. You just kind of start writing tests and then writing some code to make the test pass. And then as you write a lot of unit tests with a lot of codes to make those tests pass, you might realize that some of your classes do too much. And that's when you can use refactoring to break your existing tests and implementations into more discrete components. Personally, I think it's fine to use both approaches. I think it really depends on how much you know ahead of time about your system. If you don't know much at all about your system, you might start doing outside in and just write a test, write code to make the test pass, and just kind of keep going and refactor things as you go. But if you have a good idea of how you might break things apart, you could do inside out and kind of break things into discrete components kind of ahead of time and do TDD against that. I don't think it matters too much which way you go. The idea is you're still doing test-driven development, and that at all times you still have 100% code coverage. So let's look at how we can apply that to web applications. We looked earlier on at the different architectural layers: view, controller, command, service, and repository. As I mentioned earlier, I like to ignore the view and the controller, just kind of delay that concern until much later. And to really start, and most times I'm able to do inside out TDD, starting at the repository and then building up to the service. So the flow might look like this. First, you write a repository in a test-driven way. Then you write a service in a test-driven way, which would use the repository. And based on what your needs are, you might inject a concrete implementation of that repository or a mocked implementation of your repository. And And the reason to do one or the other could have to do with, speed. Sometimes you don't want to invoke even if it's an in-memory database, you might not want to invoke your entire data layer, because the service really doesn't care about what is returned. It only cares about, you only care about the fact that your repository did call your, sorry. You only care about the fact that your service called the repository. You don't really care about the value that was returned by the repository. So in that case, you could inject a mocked repository. It's really up to you. So, I want to be able to show these concepts in a more concrete way. And so I came up with a ride hailing application. And this is a concept diagram of some aspects of it, right? You could have a user could have more than one role, right? A user could be a passenger and the user could be a driver. Could be one or the other, or they could be both. There are locations. If you look at a ride is going to have a departure and a destination. It could have it's definitely going to have a passenger and a driver. And then, a ride is going to go through different life cycles. It could be start out, it's requested, then it gets accepted, then it's in progress. It could get canceled, or it could get rejected, or it could get completed, or it could expire. These are some examples of some, life cycles of a ride. So I've actually built this in my repo, in the master branch. I've got this implemented in a set of unit tests. And it took me 4.5 hours to do it. I've actually got it recorded in a set of videos that I stitched together. So that's the time that it took me. It's about 30 tests. So here I'm going to show an example of just building out a user repository. So we're going to start with making a repository for a user. So remember our base test class that we looked at earlier. So this is that same base test class. We're going to extend it. So here I created a class called user repository test, which extends app test case. And the first thing that I'm doing is I'm instantiating a user repository class, which does not exist. So my test is in red. So then I create the class. Now my test is in green. Now I'm instantiating a user entity which does not exist yet. See, app user not found, so my test is red. And so I just keep going back and forth, red, green, to a point where I end up with working code, where I have a user repository on which I called a save method, to which I pass the instance of a new user entity. And I want to make sure that the ID of the user is more than 0. And if I do that, it means that my ORM did its job. It actually saved it. So now the next method I'm building is get user by ID. Now that I have a saved user, I'm going to try to get the user by ID. So I skipped a bunch of steps. But basically now I end up with test get user by ID. Again, I create a new user, I save it, so that's my given. In my when I call my get user by ID 1, and I save that in my test user, I make sure that the retrieve user's ID is 1. And on the right, that's the implementation that I wrote to make this test pass. And I use DQL, the Doctrine Query Language. We could do a whole nother talk on working with, Doctrine or data map or ORM. But it's pretty easy to follow. It smells like SQL. It's just a lot more fun to work with because you don't have to do inner joins. And I can show you an example of that later. Remember to ask me if you want to see more code on that. So now I want to be able to add roles to a user. I want to make a user a passenger. I also want to make a user a driver. I want to make sure that a user can have both roles. And if I try to assign the same role to a user, then I want to be able to throw an exception. So that's kind of what these next set of slides do. Test our role to user. So here you see the many-to-many relationship for roles on the user entity. And this is what's wild, right? I mean, I'm doing ORM annotations, and I'm testing that inside of my test harness. I'm not hitting my SQL. I just have my ORM that's bootstrapped against my in-memory database, and all of these are in-memory operations that are executing comfortably inside of my test harness. So with each passing test, I have a high level of confidence that my data-driven operations are actually accurate. I can actually ship that code. All right, so this was for the repository. Now I'm going to make a service which uses that repository. So again, user service test extends app test case. And I'm calling a new user service, which does not exist, so my test is red. So now I create the user service class. So I'm green again. Now I create a new user. I call a method new user that does not exist yet on the service. And now I'm creating that method. So I'm green, but that method is doing nothing. So I want to be able to retrieve a user from that method and ensure that its first name does something meaningful, that its first name is Chris. So here all I'm doing is, I just return an instance of app user. Okay, so yeah, this is the test working. I have the user service implementation in the other tab. Sorry about that, but I'll show you the finished code. It's pretty straightforward. Okay. Now, this test was cheating because the service was just returning the new user that you passed to it, so it's not super useful. Now you actually want to get a saved user, a user that was saved by your repository. So I'm going to try to retrieve a user by ID from the service. And to do that, sorry, it's a bit confusing because I skipped a number of steps, but to make get user by ID work, I bootstrapped the repository to the service. So I could actually retrieve the user by ID using the repository. And what it looks like is right here. Here's my user service class. In the constructor of it, I expect a user repository. And I modified my new user method to call my user repository to save it so that when I call get user by ID, now I can also call user repository get user by ID and pass it, and it retrieves the actual user. So that's kind of how I got this test to pass right here. So let me show you kind of the finished service test with its implementation. So this is my user service test class on the left. And then here's the implementation on the right. It's pretty straightforward. It doesn't do much because much of it is handled by the repository. And then here's the repository, the finished repository class. So that's all of it. It has a way to save a user that was passed to it, and it calls the entity manager. And then it has a way to retrieve a user by ID, as we saw earlier. And then here's my user entity. It has all of the ORM annotations. So this is the top of it, and this is, you know, with sorry, this is the top of it with all of the properties, and these are the methods that are being used by the tests. And when I work with entities, I don't write a method in an entity that is not needed by the test. So you may be tempted when you write an entity to put a bunch of getters and setters. Just don't do that. You know, unless you need it in your test, you shouldn't build it. So here's my role entity. So it can be a passenger or a driver. So once you've done all that, you've got end-to-end functionality working in your test harness. From here, it's very easy. Every ORM, whether it's Hibernate or Doctrine, has a utility to build out an SQL migration file from all of the entities that you have in scope. So in Doctrine, you can use Doctrine diff. I forgot what the command is with Hibernate. And then from here, you can do a number of things, right? You can map some routes directly to your service methods because the app is pretty simple, and you may have somebody who's ready to build out a front-end user interface, and they'd be happy to call your service methods in a RESTful way. So you should be able to expose RESTful endpoints using your framework straight to your service methods. Then you can deploy the code, to your test server for anybody to play with it, or on your local machines. And then obviously you want to run those migrations, right? First you generate the migration files, and then you run them. So I have all this code on my GitHub. I have a link right here. So I link to the slides in the meetup room, so you'll be able to download them. Jimmy, you're okay?
Yeah, just unmuting so you can hear for questions.
All right, cool. So I've got some more reading here. A lot of people will challenge test-driven development. That's fair. There are a lot of challenges with it. So Uncle Bob tends to address them in a very methodical way. I highly recommend reading those articles. I highly recommend the book by Gerard Mezaros on XUnit patterns. If you have a lot of code today, you might look at Martin Fowler's refactoring book, a lot of really good patterns. Michael Feather's legacy codebook is wildly impactful in bringing tests on an existing code base, and it shows you a lot of incremental refactoring patterns to safely add unit tests to an existing code base, so it's easier going forward also to do test-driven development. And at a high level, the benefits of the process that I just showed is that you can build end-to-end functionality inside of your test harness. You're spending a lot less time with your browser, with your MySQL, Postgres. You're spending a lot less time clicking around in your web browser because you do all your testing in your unit tests. It's a lot easier to get in the zone and stay in it. And then if somebody interrupts you and somebody pulls you into a meeting and you want to get back to the code you were doing, it's really nice because you can look at your last couple unit tests and it tells you exactly where you left off. So you can really get back into a high level of productivity. With this, you don't have to worry too much about optimal design because of the virtue of test-driven development. You can always improve the code. And in the end, you achieve sustained velocity. You can start out fast and you can stay fast because you're always working in your test harness. You're not doing a lot of those throwaway activities, and you can always improve your code. You get 100% code coverage for free because it's test-driven development. And in the end, your unit tests are the living and breathing documentation of your code. You really, when you read Uncle Bob's clean code book, he'll definitely tell you his opinion about comments. I happen to share that opinion as well. You don't need any comments because you have clean code and you have test coverage around your code. So I recommend doing TDD even when prototyping. You want to see if something's going to work. Again, if you follow these procedures, you can get things out the door really quickly, even if it's not an optimal design. If it does get successful, you will have a solid foundation to build on. And it works when building simple things or complex things. And so that was test-driven development. So we looked at all these topics trying to culminate toward test-driven development in a way that makes things fun. Some takeaways I'd like you guys to keep in mind is that overall better software keeps you in business. It really fuels true agility and sustained agility. And overall, it makes things more fun. And it's really had a big impact on us. And in the end, you want to be doing a whole lot less of, Shawshank Redemption, crawling through a river of crap. And you want to do a whole lot more of writing better software by leveraging test-driven development, clean code, and design patterns, such that when you do that, you are able to fully leverage your agile stack, your Scrum and continuous integration and continuous delivery and your framework. And when that happens, you are able to release new features at a constant pace, and your business value can just keep increasing. And then in the end, you just kind of come out clean on the other end. So that was it. This is me. I also happen to be hiring in Austin, Texas. So here's the link to it. And with that, I'll open it up to questions.
Yeah, so is there a point where you say, hey, I'm doing these unit tests for this class, but maybe you've got a sort of a parent class, but a class that calls these other classes and tends to orchestrate things? Do you have these much higher level unit tests for that class further up the hierarchy that tests all the subsystems zillions of different ways? Do you put that in your...
Right. So, yeah. So, if you commit to test-driven development, those higher level classes, you're also going to build them in a test-driven way, right? And what you might do is do inside out, where you start out with kind of your bottom dependency. You build that in a test-driven way, right? Then you build one layer up in a test-driven way, and you might inject that lower level layer as a dependency of it, and you could use a concrete implementation, or you can use a fake implementation. In the end, though, you don't need to repeat at the higher layer. You don't need to repeat all of the lower layer use cases, right?
But you can get these implementation spaces, and I'm wondering, do you just look for the border cases? Do you look for, do you have a strategy to how you approach your test space?
Right. I mean, you basically want to cover each layer's permutations fully, right? So if your service layer does nothing but return what the repository does, you don't need to write a bunch of unit tests to try all the cases that you've already covered in your repository, right? You want to try to cover the lower layers use cases in a test-driven way, and then your higher layer might only need a couple of tests, really, because if all it does is invoke the lower layer and it doesn't really care about the output of it because it's just going to spit it out, you don't need to do yeah.
Very time sensitive VR apps where you have to hit your 90-second frame rate, and you have to deliver all the things. Can you hear me okay?
No, you might need to speak up, and maybe and maybe Jamie can chime in as well, because he.
Oh, I just, can you hear me a little better now?
Yeah.
Okay. So I'm wondering, in a real-time application, where you on a tight deadline to meet, like your vertical refresh or something, and slight timing differences can affect, the state of the system. do you have a different approach to testing? So these kinds of permutation spaces are unbounded, right? So I guess the question is how do you have an approach to determining, hey, this is enough?
It's hard to try to solve the problem in an abstract without kind of seeing the code.
I guess so. For instance, if you're getting a variable frame rate, for example, and you're advancing the time state of your world by the variable time that passed, and it's a floating point number, you could very easily be plugging that into an equation somewhere where, depending on what number you get to, it blows up some operation into a NAND or something, right? But it's only if you hit this little guy and the perturbations over time of the frame rate based on the load, what you're doing, only in this one time you get it just right, and you trigger that event. But it's the sort of thing where it's kind of chaotic and hard to model, right? And so I'm wondering, for these very broad open spaces, inputs, how do you?
Yeah, I think I'm gonna.
Yeah.
So what you're talking about is extra dependencies. Time is one of them, right? So if you're dependent on time, then maybe there's a problem with the design. So right now, if we're talking about service layers and repository layers, the service layer is so dependent on the repository that its logic is based on what happened with the repository, that it's probably too tightly coupled. Even though you pass in that dependency, you might be too coupled. So in your example, you may just be too coupled with time. And that's really hard to do in tests. It's just inherently difficult because every time you run the test, the clock cycle could be different the next time.
So I guess never minding time, I mean, obviously with real-time apps, you don't have a choice, right? But I guess outside of the time question, more for the like, hey, I'm going to do some image processing question, right? And you know you're trying to get this edge detection out of it. You're trying to find the right image to break the edge detection out of it, right? So how do you potentially
I think a lot of it, you're going to, for every type of software project, right? A lot of it is going to come down to, loose coupling, right? Dependencies is one of the hardest thing to solve in software. And, as Uncle Bob put it in one of his videos, he's saying that, the essence of OOP is to manage dependencies. And, in this narrow lens of web applications, I put forth a way to kind of manage those dependencies so that you end up with a framework that is more conducive to test-driven development. And I think that with every type of software system that you work with, you're going to want to do something similar to try to define what your architectural layers should be and find ways that you can design your system in a way that it's as loosely coupled as possible, so that you can build things incrementally in a test-driven way. And it's, in web applications, it's kind of easy to do with what I just showed, right? Although it took us a while to kind of get there, but it's, it's pretty easy to do. In some other project, it, may be different. It may be a lot harder. I don't know.
Well, here's an example of what I mean. So you had an example where you did the Chris Holland name, right? But a typical thing that fucks up databases is you start one of the names with a space, or you use a special character, or something that might be interpretable as SQL, right? But I didn't see you mention those cases, presumably because you don't need them. But I'm wondering how you scope your test cases, right?
Are you saying like when you have so much different input that you can't test every single thing that that might throw some bug or throw something off down the line? Is that?
Yeah, I'm just wondering how you pick the scope of the test to.
Well, remember try to think of it in a tester. What you're describing sounds to me like I have existing code and I want to write some test after it, right? Try to think of it as I'm starting new and I'm doing test-driven development. So with each kind of case, you want to write a test to handle that case, and you want to write just enough code to make that test pass. And if there's some other character combination that you want to try out, you're gonna write another test, and then you're gonna write some code to make that test pass after it, right? And you can break it apart in different test classes. You can refactor your way into that. It doesn't matter that much, but that's really the flow that you want to achieve if you're doing test-driven development.
You're saying just start with get it done. I think this is enough, and then if it breaks later because you didn't anticipate this input.
Right, and that's really, it's important to stress. Test-driven development does not mean bug-free system. Absolutely not. But that's kind of the beauty of it is, you're often going to not think about certain edge cases, right? And then you get into QA or users use your app, and then a new bug gets created because you didn't think of that edge case. That's perfectly okay and perfectly normal. What you do in that instance, you go back to your test with the evidence of this bug. You write a test in your test suite that will replicate this bug's behavior. And so your test should turn red. And then you just write just enough code not to make your test pass, right? And then when you ship to QA, it's almost guaranteed to be bug-free, assuming you wrote the right assertion that correctly replicates the bug. And my team and we run into this all the time. So some of the applications that we build have a lot of use cases. I mean, and a lot of edge cases against those use cases. There was this one time where, one of my engineers had gone on vacation, and we had a release in our QA process, and they found an edge case. They found a bug, right? And he was on vacation, and I didn't want to bug him, right? So I figured I could take a stab at fixing the code. Based on the symptoms of what QA reported, I just looked at the code, and his code was really clean. I mean, just beautifully clean. And so I start formulating a theory as to what the issue might be. Once I arrived at a theory, I went into my test, which there was a test for that class basically, and the test was passing. Now I augmented the test to make it fail. I augmented the test to replicate the condition that we didn't account for that QA caught. So I augmented the test to make it turn red, so it fails, and sure enough, it failed. And now I just wrote just enough code to make that test pass, and the test turned green. Then I shipped it to QA, and the bug was resolved. I didn't have to bug Josh because 1, the code was clean, and 2, he had 100% coverage on his code, and 3, I was able to take his existing test and make it fail to replicate the condition that QA had found.
So do you basically turn every bug report into a test?
Exactly. Yeah. Every bug that QA finds, or your users find, when you modify your code, I mean, right now we're at a place where there is literally no code that is changed without a test having changed ahead of that. And when I looked at the commits that come in, if I see some code that was changed without a unit test with it, I'm like, no, okay, I know there's something wrong there, right? So yeah, basically any missed use case, any bug, any edge case going forward, you just write a test for it, and you just make the code pass, and it's really quick. And it's a lot quicker, really, than having to click in the user interface to try to replicate the behavior. If you can make the test to replicate the behavior, then you're good.
Thanks.
Yeah, so overall, I wanted to, kind of give this talk because following these practices has had a mind-blowing impact on our ability to get things done faster than any other department. It's been very, very impactful, and it makes things a lot of fun. And we have a lot of the code that we have, some we inherited, some we built, some we refactored, but basically we have this clean area that is 100% covered. I gather some stats. Should bear with me for a second. Yeah, on one project I have 35 service classes, 107 commands, and overall I have over 2,500 tests. And those 2,500 tests represent 100% coverage of all of those commands, service, and repositories. 107 commands, 35 services, and 37 repositories. And all of that code is 100% covered. Every day we get to play in that code is the best day of our life. Every day that we have to be in our legacy code is just not fun, right? And so
I got a question. So in some projects, people tend to have ownership and they're part of the code. Do you feel that unit tests kind of promote a team ownership and there's no longer a, hey, don't touch my code?
Yeah, absolutely. And that's the beauty of this is, with the example that I just gave with, one of the engineers on the team being literally on vacation, right? I was able to get into his code and fix it, and it wasn't a big deal at all. And I've written a bunch of code in there as well, which the team has been able to kind of get in there and augment, refactor, fix some bugs, and the code is readable and it's 100% tested, right? So any kind of troubleshooting that needs to happen, you can just kind of start at the unit test, and it just make things so much easier to work with. I mean, it's unbelievable because you start out modifying existing code that is 100% covered, and with all the tests passing, so then when you're done doing whatever small or big changes you just did, you just need to end up in the same state. And so, yes, it's absolutely great to promote collective ownership of the code base versus, hey, you wrote this cryptic piece of code, you own it now forever, right? You don't want that. You want to be able to have other people do things with your code. And test-driven development has been wildly impactful for us, for sure.
This isn't really a question, but I've heard a lot of lip service paid to test-driven development in the past, even had like bosses and managers who talk about how important it is and how much they like it. But I've yet to ever actually be on a team that actually does it. They're just like, oh yeah, we're all about it. And you show up for work without a unit test and sound like you never do it. But this is really convincing. I'm going to hope to go back to my team and try and convince them to actually start doing it.
That's legacy system and try to do TDD into a system that you can't write tests for. It's impossible.
Yeah.
You have to start small somewhere.
Yeah. And what you just mentioned, I can so relate to that because that's been the bane of my existence throughout my career. Is I hear everybody, oh yeah, test-driven development. You see that on everybody's resume. Unit test, test-driven development. Okay. Then I ask, well, cool. So how do you do it? Well, I don't know. I write unit tests. Okay. And it's, it's difficult, it's difficult until you've done the diligence to look at a lot of the existing wisdom that has existed, right? And when, working with Jamie and working with Josh on the line, we've done that. We've been able to collectively kind of look at all this wisdom and kind of apply it to everything that we do daily and kind of get over those hurdles, right? And it's just so good. It makes it so much more fun for sure.
You mentioned big changes. So when you're doing a big Refactor, right? Do you start out with refactoring the tests first and making sure those business rules or business logic is covered, and then changing the code, or do you go by refactoring the code first? Like if it's a large enough refactor that individual tests would fail.
Yeah, I mean, so if you start from a code base that is 100% code covered, there are a bunch of different ways you can do it, but really I'll go in my IDE and I'll start renaming things and extracting things and then kind of anticipate what will break. And then I just run my test suite, and then things are going to blow up in the test suite. And then I start, fixing the root cause of what blows up in the test suite. Sometimes, if you're working in an IDE, the nice thing with an IDE is if you rename a class, if you rename a method, it's going to do it through the entire project, including your tests, right? Things get a bit more dicey if you start adding an argument, to things, but then your tests are going to blow up. So, you modify your tests accordingly. Keep in mind that if you keep adding arguments to things, that could be considered a code smell. You want to have a limited number of arguments to methods, but that's a whole other story. But yeah, things tend to break kind of all over the place, but it's really quick to fix most of the time. Yeah.